My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 484. In this lecture, we will try to understand agglomerative clustering algorithm with a nice graphical example. Again, we are using the same slideshow. This is the same slideshow that which we are discussing from past few classes. Anyway, I will provide this particular link in comment section. So let's understand this. Let's understand the algorithm in plain English. Then we will go and see visually what it is. First step is to compute the proximity matrix, which means given points p1, p2, p3, so on, p4, p5, you have to compute the matrix which contains the similarity values between every pair of points. Between every pair of points means between p1, p2, between p1, p3, p1, p4, p1, p5, like that. You need not compute distance between p1 and p2. Why? Because it's 0. This p between p2 and p2 is 0. Between p3 and p3 is 0. Between p4 and p4, between p5 and p5 is 0. Proximity matrix or distance matrix or similarity matrix is one and the same. So proximity is basically how close things are or how similar things are. Without these, you can't do anything. But once if you have this, you need to have proximity matrix, and each data point is a cluster onto itself. Then you have the loop here. Just observe, we have loop here. What is that loop? Repeat until, isn't it? You have loop here which says merge two closest clusters. What do you have to do? Merge two closest clusters. In this case, what happens if you see that the p2 and p3 have smallest values and smallest values, if you observe among all of these pairs, you can ignore p1 and p1. You can ignore because the distance between p1 to itself is 0. Look at only, we have to look at only off diagonal elements. We have to look at only off diagonal elements. Of diagonal elements. What is the reason? Diagonal elements has got value 0. Look at only off diagonal elements in this matrix. If you see that distance between or the similarity between p2 and p3, let's assume similarity between p2 and p3 is small. Let's assume similarity between p2 and p3 is small compared to all other values in this particular matrix, isn't it? If the distance is small, you group them, you merge them into one large cluster. That's what it says. Merge these two clusters, merge them into one large cluster. Once if you merge them into one cluster, now you update your proximity matrix. After merging, what you have to do? You have to update proximity matrix. Initially you have p1, p2, p3, so p4, p5. After you merge p2 and p3, just I am assuming distance between p2 and p3 is small compared to all other values. In that case, what I have to do? Now the proximity matrix must be updated. Just see, now p2, p3 become a cluster, p2, p3 become a cluster. You need not bother about the values of principal diagonal. Why? Because cluster to itself, the value is 0. You have to take care of only off diagonal elements, isn't it? p2 and p3 are merged to create a cluster. Now you need to compute distance between the new cluster. What is the new cluster? p2 union p3. You need to compute the distance between the new cluster p2 union p3 and p1. This distance I have to calculate, isn't it? p1 and p2 you need not recompute. p1 and, let me say, p1 and p4. p1 and p4, I need not compute this distance. We already computed this. This value already computed in our previous. Here we already computed Distance between P1 and P4 is already calculated, isn't it? Therefore, now you need not to compute the distance between now you need to compute the distance between the new cluster P2 union P3 and P1. P1 and P4 you need not compute. That's what I'm saying. Yes, this whole row, which whole row? This whole row, this entire row, this P2 union P3, this whole row needs to be updated. This whole column, this column needs to be, this P2 union P3 column needs to be updated, because you merged P2 and P3. You need to compute the distance between P4 and P2 union P3. That's what is the update stage. So the repeat, what it says, repeat logical loop is simple. We merge the two clusters and you update the proximity matrix and keep doing this loop until only single cluster remains. That's what it says. Until single cluster remains. Just see, until only one cluster remains. The most important operation here is how to compute the proximity of two clusters. How do you compute similarity or distance? Similarity is same as proximity between two clusters. That's the two clusters. That's the big question, because once if you figure out that this whole algorithm falls in place, of course you need to be careful how you update your proximity matrix. It's very straightforward. The big question here is, how do you measure similarity or proximity or distance between two clusters? So let's look at a graphical example here. Imagine if these are my points. Just imagine my points are P1, P2, P3, so on. First I compute proximity matrix or similarity matrix. Now each point is a cluster onto itself. Let's assume I have 12 points here. Each point is a cluster onto itself at the starting stage. Now I compute the proximity between all of them. Now what happens after a while? After a while is I group the points, maybe P1, P2. Let me assume I group the points P1 and P2 got grouped into cluster C1. Let me assume this P1, P2 grouped into cluster. Let me say this one is P1, P2. This is, let me say, cluster C1. This is cluster C1, and P3 and P4 got grouped into which form? Cluster C2. Now these clusters I need to recompute my proximity matrix. After merging some steps, we have some clusters. Suppose you want to group cluster C2 and cluster C5. Let me say I want to group cluster C2 and cluster C5. So what happens to your proximity matrix? Now your proximity matrix has C2 union. Your proximity matrix will have C2 union C5 as a new entry. Now you have to recompute all these values. Which values I have to recompute? These values. Which values? We want to merge two clusters here and update the proximity matrix. That's what it says, isn't it? Just see, this one is this one. Yes. Anyway, C2 and C5 are merged. Therefore, what I have to do? I need to update this one. Just see, this column. This column has to be updated. This row has to be updated, isn't it? C2, what it says now. Your proxy after merging some steps, we have some clusters. Suppose you want to group cluster C2 and cluster C5. So what happens to your proximity matrix? Now your proximity matrix has C2 union C5 as new entry. Now you have to recompute this particular row and this particular column, isn't it? Other values still remain same as previous. Other values still remain same remain same as previous, because the distance between C1 and C3, for example, the distance between C1 and C3 is already computed for you in the previous stage itself. So whichever two clusters you merge, the corresponding row and column need to be updated. But the big question here is, how do you update your proximity matrix? How do you define intercluster similarity? That's the big question. Suppose, imagine if I have cluster of points here C1 and other cluster of points C2. How do I measure? Let me say I have points. Let me say this is C1. Let me say this is C1. Let me say this is C2, isn't it? If I cluster points here C1 and C2, C1 and C2, how do I measure the similarity or the proximity between these two clusters C1 and C2? There are multiple approaches. First one is, let me say, min approach, max approach, group average approach, distance between centroids, other methods driven by an objective function, isn't it? That we will discuss these approaches in my next lecture. Fundamental idea is very simple. You keep grouping them. The only key idea is, how do you measure the similarity between two clusters? Once if you figure that out, this algorithm is very simple to implement. Actually, I would recommend you to implement this algorithm in Python, because remember, Python has a data structure called set. In Python we have a data structure called set, which is extremely useful for something like this, because at the end of the day, what you are doing is set unions, isn't it? Set unions, merging is nothing but set union, isn't it? Just go through this lecture. In my next lecture, I will discuss about these proximity methods like min, max. We will try to understand all these methods with numerical illustrations also. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.